Hello everyone. Today we will find the estimate for the normal distribution. We know that the mean and the variance sigma square, and we will going to be estimate these two parameters. We know that any PDF of a normal distribution given the mu and the sigma square is defined as 1 by root 2 pi sigma square e to the power minus xi minus mu whole square divided by 2 sigma square. So this is the PDF of normal distribution. So very first thing what we have to do, we have to take the product both side, x mu sigma square 1 up to n. So this is the 1 up to n product, root over 2 pi sigma square e to the power minus xi minus mu squared to sigma square. See, this expression, the expression of taking the product for the PDF of any distribution, it is nothing but the likelihood L of the parameter of interest, suppose mu or the sigma square given the observation. So we are taking actually the likelihood. So whenever this product will apply, there is a two parts, see this one and this one, and they are multiplying to each other. So I will give each of this as a product, 2 pi sigma square 1 up to n e to the power minus xi minus mu whole square divided by 2 sigma square. So that is it. And after that, when I just apply this product one, I will have the same. This is I basically, and if you see there in this part, there is no terms which has a subscript of I, but in these terms, does here any element who have any subscript of I? Yes, this element, but this part doesn't consist any I as a subscript, and no variable does it here. So what is it is concerned with respect to this product I 1 up to n, it's a constant. And basically you have to understand any product situation, suppose 1 up to 3 of this product of 4, then we will have 4 into 4 into 4. So this constant will be multiplied by n times, or this one we can write it 4 to the power 3. So now at this part here, what I will write this constant as 2 pi sigma square to the raised to the power n, because there is n time multiplying to each other like this similar way. So after that, as I mentioned, there is any variable contains I. So what I will have to here add is that see, here is a very interesting fact will be concerning in this part. Let me explain you here. See, suppose I have e to the power 4 into e to the power 3, then what we will have e to the power 7. How? Because this is e to the power 4 plus 3. So whenever so as a product I 1 up to n, so it will be multiplied n times. So we will have this ease term or the Euler term n times, and if we multiply that n times like this one, then the above term will be summation 4 plus 3. So here the addition was applied, summation was applied. So what will happen, this e raised to the power summation I 1 up to n xi minus mu whole to the power square to sigma square. So summation was been applied. And why this summation applied? Because this some kind of a situation is occurring here. So next, what I can write similarly, at this part nothing goes happened, 2 pi sigma squared whole to the power n. And if you look at here, see the i's term contains this variable x, and it is at the numerator. So I will have the summation only for the numerator part, not for the denominator. So e to the power minus 2 sigma square summation xi minus mu squared. So this is the final term for the likelihood. For the likelihood, or you can say that the product term. So next thing is very important, and it is nothing but to taking the logarithm. Taking the logarithm. So here the final term was the product. So I will take the log of this product of this f of xi given mu and sigma square as a variable, and what I had at that part, log of something. So first of all, log of 1 by root 2 pi sigma squared to the power n, then it will be plus log of e to the power minus summation xi minus mu whole square to sigma square. So that is what I will have here. And after that, this logarithm, whenever it will be applied, this part, say log of a to the power b, then it will be b log of a. Okay, so in log of 1 by root 2 pi sigma squared plus, similarly this part will be here, then it will be minus summation xi minus mu whole square to sigma squared, and log e. What is log e? Log e is nothing but 1. Okay, so we will remaining with this part only. And now there's an important fact coming here, and it is about see, in this log of a divided by b, what we will have? Log of a minus log of b, right? So similarly that will be happen here, log of 1 minus log of root 2 pi sigma squared, minus at that part it is nothing but 1 by 2 sigma square summation xi minus mu whole square. So n log 1 is nothing but 0, so n minus n log of root, so I will take out the root also, sigma square, and it will be half, minus 1 by sigma squared summation xi minus mu whole square, this I 1 up to n, and minus n. See, this half will be at the beginning, so log of 2 pi sigma square minus 2 sigma square summation xi minus mu whole square. So that is it for the taking after logarithm of the log of the likelihood. And now I have to estimate the parameter, first of all the mu. So what I have to do, first of all, the very first, what I have to do for that, to find out this one, I have to take the derivative of with respect to mu of this, say you can say this one, or you can write it like log of L, the first derivative. When you just see there is no term related to this mu, so it will be 0 minus, and whenever you just go for derivating this part, see 1 by 2 sigma square, and this 2 will be come out there, and you will remain with xi minus mu. See how this I will getting from, suppose d by dx of x square, then it will be 2x. The same thing was applied in here, and if you see, uh, after that we will the log of L d mu hat, we will consider it equal to 0. Then what we will have, we will have minus 1 by 2 sigma square to summation xi minus mu. This two cancel out, is equal to 0. Then what we'll have, see, we will now apply this summation 1 up to n. So then it will be very much like summation xi minus n mu is equal to 0. And after that, if we calculate this one, we will find out mu hat is equal to 1 by n summation xi, and this is the nothing but the estimate for the parameter mu. After this we will also estimate the parameter sigma square. Now we have to estimate the sigma square or the variance, so we will begin with this whole line. So what we have was minus n by 2 log of 2 pi sigma squared minus 1 by sigma squared minus 2 sigma square, sorry, summation xi minus mu whole square 1 up to n. So we was have this one. Now we have to derivative it with respect to log of L sigma squared. Then what we will have, see, here what we will happen is that suppose d by dx of log of 1 by, sorry, log of x, say log of x, then it will be 1 by x, right? So same thing will be happen here, and it will be 1 by 2 pi sigma square, and but this is not x, and so again we will derivative it, then there will be 2 pi multiplying, and minus, if you look at this part, and when you just go for derivative, this one, these parts are constant, but this is not. So here will be 1 by 2 summation 1 up to n xi minus mu whole square, this is the constant part, and 1 by sigma square, if you derivative this one, there will be minus 1 by sigma to the power 4. How? Suppose d by dx of 1 by x, then it will be minus 1 by x square. The same thing was applied in here. Now we can write it here like n by 2, this 2 pi will be cancelled out, so we will remain with sigma squared minus, we can write it plus 1 by 2 sigma to the power 4 summation 1 up to n xi minus mu whole squared. And if you take the derivative to sigma to the power 4, if you just take in common this one, and what we will left with, we will left with sigma square minus n sigma square plus 1 up to n xi minus mu whole squared, and we have to take the log of L d sigma square is equal to 0. then what will happen, uh, minus n sigma square plus summation 1 up to n xi minus mu is equal to 2 sigma square 2 sigma to the 4 is equal to 0. Then minus n sigma square plus summation xi minus mu whole square is equal to 0. Then what we can write here is that minus n sigma square is equal to minus summation xi minus mu whole square. And now what we can write, sigma square is equal to 1 by n summation I 1 up to n xi minus mu whole square. Yeah, so this is what we get, our estimate for the variance. We estimate previously mean, now we are taking variance, so we estimate the parameters of normal distribution, and this approach also known as maximum likelihood estimation or MLE. Thank you very much.